Trying the headset again, staring at the screen to see if it's gonna drop me again. Nonetheless, oops, I have some technical glitches there. Anyway, so uh, the microphone seems to be working. So this is a nice review paper on why climate mitigation has not worked despite years of negotiations, agreements, and mitigation actions. 3 decades of climate mitigation. Why haven't we bent the global emissions curve? Good question. The keywords, of course, are climate mitigation, energy transitions, lock ins, power, knowledge traditions, societal transformations. Lock ins are basically investments in fossil fuel structures like internal combustion engine production. The more you invest in them or the less you phase them out, the more you are locked into using fossil fuels for economic reasons, of course, and profit motives. So there is all kind of tricky situations. What's the abstract? Despite 3 decades of political efforts and a wealth of research on the causes and catastrophic impacts of climate change, global carbon dioxide emissions have continued to rise and are 60% higher today than they were in 1990. Exploring this rise through 9 thematic lenses covering issues of climate governance, the fossil fuel industry, geopolitics, economics, mitigation modeling, energy systems, inequity, lifestyles, and social imaginaries, which is basically about the lifestyles we could be having in a carbon free world. This report draws out multifaceted reasons for our collective failure with these lenses to bend the global emissions curve. However, a common thread that emerges across the reviewed literature is the central role of power manifest in many forms from a dogmatical political, social, political economic hegemony and influential vested interests like oil companies to narrow techno-economic mindsets and ideologies of control. Synthesizing the various impediments to mitigation reveals how delivering on the commitments enshrined in the Paris Agreement now requires an urgent and unprecedented transformation away from today's carbon and energy intensive development paradigm. Right? Are we really even able to go away from this? I've discussed the evolutionary baggage we have that may prevent collective global action elsewhere in uh, the series under climate and human evolution, which I'll also post here in this series under new findings in climate change. So I place the podcasts in different sections based on their relevance. Of course, you have know all the definitions: IPCC, Intergovernmental Panel on Climate Change, United Nations Framework Convention on Climate Change, the Kyoto Protocol, which was the international treaty that included legally binding requirements for industrialized nations to limit or reduce their greenhouse gas emissions and failed fantastically. Paris Agreement is the new one. It's the international treaty in which 191 countries have committed to limit global average temperature rise to well below 2 degrees C and pursue 1.5 degrees C through voluntary, nationally determined contributions. Is it more democratic, hence more likely to succeed? Well, as we are saying, mitigation hasn't been working and adaptation is a disaster in terms of finance, expertise, technology transfer, etc. So we have to worry about uh, how well we will do when we get to the monitoring, verification, reporting phases of the Paris Agreement commitments through the nationally determined contributions. CO2 is the dominant greenhouse gas, and greenhouse gases include others like methane, N2O, HCF, HFCs, PFCs, and SF6, along with CO2. Negative emission technology is a fancy descriptor for technologically focusing the approaches for carbon dioxide removal, such as direct air capture, bioenergy with carbon capture and storage, etc. Are we going to get there? Why is it called negative emission technologies? Because we will have irreducible emissions, but carbon capture, sorry, is supposed to take out more than we are emitting, so negative emissions. Extractivism, the exploitation, control, and export of raw materials, mainly from the developing global south, to fuel the industrial development of the global north, like Indonesia supplying cobalt, nickel, lithium, etc., to do the renewable energy, the battery technology and EVs for the rich world. Integrated assessment models, generally categorized as either process and energy-based models or cost-benefit-based models, which are used for developing the future scenarios, which we have discussed extensively elsewhere. There are a lot of issues with them, but they basically provide the emissions estimates for the future for different pathways, and then those are fed to the Earth system models or climate models. Sometimes there is an iteration between them, because if climate has a feedback, then again your mitigation pathways have to change, and so on. Carbon markets made up of emission credits or offsets that can be traded through emissions trading schemes, also known as cap and trade. Carbon capture and storage, carbon dioxide removal, of course, is an umbrella term for techniques that sequester and store carbon dioxide from the atmosphere by technical or ecological means. BECS is the bioenergy with carbon capture and storage. Lots of issues there in terms of competition for food, water, space, land, etc. Common but differentiated responsibilities and respective capabilities, CBDR and RC, are something that have been around. Basically, as we said, 1990 baseline is used for many things, but uh, cumulative carbon is causing the warming, and warming is linearly proportional to cumulative carbon since industrial revolution. So we all have to do things. We are all have responsibilities, but they are differentiated because rich countries have contributed more, they are capable of doing more, they are financially able to handle more, and so on and so forth. Social imaginaries are collective images of how we might live in a counterfactual world, or in a world where we reached complete decarbonization of some sort, or remained or reached sustainable pathways using carbon capture, let's say. Okay. The introduction: 3 decades of insufficient climate action. Again, I'm being very, very brief here. It's a nice long paper with lots of really nice references and lots of very useful discussions, especially of these 9 lenses they talk about. But I'm going to just provide you a brief introduction in 2 podcasts so that you can follow up the details if you are interested. Drawing on an already long standing and growing body of research, the first assessment report of the Intergovernmental Panel on Climate Change was published in 1990. Scientifically informed warnings of the potentially catastrophic impacts of climate change have since sparked a myriad of political responses to the challenges posed by rising emissions. This descriptor, catastrophic impacts, you want to decide for yourself whether that's a good descriptor, whether it's too strong or too weak or not strong enough, and so on and so forth, right? So international level, we have the UNFCCC that started in 1992, and there are many financing mechanisms discussed and supposedly in place, but there are lots of reports on how they are not working or not working as well as they should, and so on. So, Global Environmental Facility, Green Climate Fund, and so on. And then the CO2, of course, continues to increase and even accelerate. So now it's 60% higher than they were in 1990, carbon emissions, as we will see in a minute. Considering the unprecedented risks of projected levels of warming, what are possible explanations for this continued rise in global emissions and the ongoing failure to bend the curve? This article aims to address this challenging question in the hope that it may lend important insights into ongoing climate mitigation efforts while elucidating key questions for future research and action on climate change. I will just read the blurbs from each section, and then this, of course, is a figure that is showing global carbon dioxide emissions in gigatons of CO2, not including non-CO2 greenhouse gases, and it's divided into developed countries, developing countries, and least developed countries. And emissions of least developed countries even now still don't really show up, but they may be doing other environmental harm like deforestation, etc. So CO2 emissions in 2018 are 60% higher than the levels in 1990. 1990 was agreed upon as the baseline for negotiations because the West convinced China and India that they didn't know what they were doing before 1990. Wow. Let's leave it there. So the emissions from 1960, when the Keeling curve started, you can see that the developed countries are growing and maybe growing faster, of course, and developed countries haven't quite uh, reduced their emissions. So 50% of all historical CO2 emissions released in the past 3 decades. So cumulative carbon is important for warming, linearly forcing warming. Plus, we are accelerating the cumulative carbon. And of course, now developing countries are coming fairly close to developed countries, mostly because of China and India growing and ambitiously growing, and they're relying on fossil fuel, especially coal, for their energy production. Average annual carbon dioxide emissions per capita for 1990 to 2018 in tons of CO2 per year. Developed countries have 11.3 on average, developing countries down at 3, one fourth or so. Least developed countries have basically very low carbon footprint per capita. But this can be misleading because even in a country like China or India, you have a lot of rich people living at these levels and a lot of poor people living at these levels. So you're averaging over a very large range of numbers. And you can see here things like, just historic timelines. First IPCC report came out in 1990. UNFCCC was established in 1992 for handling the international negotiations. Of course, Kyoto Protocol was considered a success back in 1997 and failed for various reasons. Financial crisis hit in 2008, which produced a dip in emissions. Paris Agreement came in 2015, and COVID-19 also produced a dip in 2020. But the emissions typically accelerate after such dips because economies try to get back to normal by putting more money, stimulus funds, and so on and so forth. A global carbon budget and the Paris Agreement. The concept of a carbon budget captures the cumulative nature of CO2 emissions and implied linear relation to warming, and quantifies the total amount of emissions that can be released to stay below a certain rise in global average temperatures. So if you know that there is a linear relation between cumulative carbon and warming, and if you set a global warming target, then you can estimate the remaining budget for carbon emissions. Not very, it's a good guideline, but there are a lot of uncertainties and doesn't include non-CO2 greenhouse gases. So combining the carbon budgets as calculated by the IPCC with the temperature commitments enshrined in the Paris Agreement brings attention to the urgent need for unprecedented levels of climate mitigation without a belief in the successful deployment of planetary scale negative emissions technologies and recognizing the principles of equity underpinning the Paris Agreement. Double-digit annual mitigation rates are now required by wealthy industrialized countries. So CCUS and negative emission technologies have limitations right now in terms of scalability. How much can they really draw down? And there is additional moral hazard that carbon capture will only delay the phasing out of fossil fuels because people say, hey, we can take it out anyway, right? So these are tricky issues. Second section focuses on reviewing the 3 decades of climate mitigation through 9 thematic lenses that I mentioned. In reviewing possible reasons as to why the global emissions curve continues upwards, the first two authors of this article formulated 9 thematic lenses to structure the process. They covered the issues of international climate governance, the vested interests of the fossil fuel industry, geopolitics and militarism, economics and financialization, mitigation modeling, energy supply systems, inequity, high carbon lifestyles, and social imaginaries. These lenses were chosen to complement other recent reviews on, for example, carbon lock-ins, discourses of climate delay, and interdisciplinary research agendas. Carbon lock-in or carbon trap is, of course, the idea of building fossil fuel-based infrastructure that will be hard to remove, and energy production, of course, and the carbon trap where everything we do is carbon. So emissions negotiations based on reducing emissions is argued to be just not a good way to do or bound to fail, etc. So decarbonizing can be the focus instead of emissions reductions. Okay. Thirdly, governance, geopolitics, and vested interests. So the so-called Davos cluster engages the 3 lenses of international climate governance, the vested interests of the fossil fuel industry, and the entrenched nature of geopolitics and militarism to explore how effective mitigation has been and continues to be obstructed. The fourth one is economics, mitigation, modeling, and energy, the enabler cluster. The three different lenses captured within the enabler cluster explore ways in which orthodox schools of economics and financialization, dominant forms of mitigation, modeling, and energy supply systems have contributed to the failure to bend the global emissions curve. Finally, the fifth one is equity, lifestyles, and imaginaries, the ostrich and phoenix cluster. Ostrich is burying your head in the sand, and phoenix is something that rises out of the ashes. Final grouping of the three distinct lenses forms the ostrich and phoenix cluster, which reflects on the underlying dynamics of inequity, the psychology and social practices of high carbon lifestyles, and social imaginaries for a post-carbon future or post-carbon futures. These expose barriers to as well as possible openings for achieving the deep-seated transformation of societies needed to limit climate disruption and bend the global emissions curve. Let's look at this figure and then we'll come back and conclude with the podcast on discussion and conclusions with some summary points. This is a fairly straightforward figure that's showing primary energy supply in linear scale in exajoules starting from the Industrial Revolution. Biomass has increased, and of course, petroleum products took off in the 20th century. Coal and natural gas have also picked up natural gas more lately, but coal is not phasing out, which is a problem. Biomass, hydro, nuclear, wind, solar, geothermal are increasing, but obviously these are still dominating. If you look at the share of primary energy in percentages, then you see that uh, the biomass has dropped, but that's in a good way in the sense people used to burn a lot of biomass for cooking and so on, which is unhealthy. But now we have bioenergy, which is another type of biomass, which is showing up here. So if you do petroleum products, they have increased and flattened or decreased a little bit. Coal products have decreased but haven't died yet because many rich countries find them to be economically unviable to remove and burn, mine and burn. Natural gases are considered low emission fossil fuels by some, but as fancy footwork, it's still a fossil fuel, lesser emission than petroleum and coal. Biomass here and hydro, nuclear, wind as percentages remain remarkably low. They are growing, but they remain very low, part of the overall portfolio of energy. Primary energy supply in log scale, you can see biomass here shows a bit of an increase as opposed to the same thing as here. Total energy supply is here. Petroleum products still a big part, coal, natural gas still big part of the supply, biomass, hydro, nuclear, wind and solar have exploded here, but they have to really uh, make geothermal is grown as well, but flattening out already. But the point is, rich oil countries, can they be convinced to leave the assets in the ground, money that can be just dug up and so put in the bank? Will they agree to do that? So this is a big challenge as well. That's where the vested interests and the lock-ins come in that we talked about. Okay, so I already read this, so let's come back and conclude with discussion, some conclusions, but mainly nice table of summaries, points, and future or directions or ways forward. Okay, hopefully the sound is good, everything is kosher, and my headphone is still working. Okay.